Well, so again, if you don't have a polling device, feel free to grab one so you can participate. Oh, great. Here he is, Vinod. Hi.
Thanks. Thanks, Sharon.
Do you need this?
I don't think so, we're not. Okay, good afternoon, everybody. We're going to have a panel on Power Platform as a Service, Next Generation Cloud Platforms. And the panelists are just getting wired up, so I'm going to give them 30 seconds. I think it was a pretty interesting session, the previous one. I don't think I'll poll as to which one is going to win, otherwise it'll preempt what the judges are going to do. So, okay. I think we're ready to have the panelists come on. Yes, please come on and join. I'll introduce once you're all here. James.
Hi.
Please.
It's taking a little while to get the microphones on.
I know. Hi, Steve. We got Mario who's joining us too. So I'll get started actually, and in the meantime, Maria will join us. So it's my great pleasure to introduce our panelists. I think we are very privileged to have these illustrious folks sort of join us and give us their comments around Platform as a Service. To my immediate right is Steve Martin. He's the General Manager of Windows Azure Business Strategy for Microsoft. Please give him a hand. And on the extreme right is James Gosling. He's an advisor to Cumologic, but you may remember him as creator of Java, which we have all been touched by, so please give him a hand. And Maria. Oh, I'm not sure if she made it in. Oh, there she is. Okay. Hi there. You all heard her.
Hi. This one works.
Okay. Hello. Okay. Thanks.
You're back on.
Okay. Hello. Number 4. Okay. So obviously, we all understand cloud computing in a variety of different ways, but one of the really, popular classification and segmentation, which we're all familiar with, or is discussed a lot, is sort of the segments around infrastructure as a service, platform as a service. Just change it. Sorry about that, guys. Okay, put it to the side. So today we're going to focus in our panel on actually platform as a service. I think market projections suggest that software as a service is really well defined, sort of end business users as customers, fairly fast-growing market. I think we all understand infrastructure as a service on sort of the hardware front, most commonly defined by Amazon EC services. And so to start with, I think what I'd like to ask my panelists is, their comments on how do they look at platform as a service, what is the definition, and how it actually differentiates or how does it distinguish from infrastructure as a service? So let me start with Steve first.
So for those of you that went to the session we did this morning, we talked a little bit about platform as a service and how that relates to cloud. I think for us, one thing that's very important to point out is platform as a service is really a conversation about the level of abstraction and automation. Two very important but distinct things. As I mentioned this morning, I think all of you are doing platform as a service today. It's just a question of how much automation have you done in that mechanism. If you have two servers, you're doing platform as a service, right? It just may be an individual who's responsible for those systems, keeping them patched and maintained, load balanced, or you may be fully automated through a set of technologies. So I think a lot of the conversation that we'll have today about platform as a service is how much do you want to automate? How much is that automation worth to you? And what are you willing to give up to get it? Because in many cases you'll find the higher you go in the stack, the more control over the underlying components you may have to give up for automation. So I think that would sum it up for us.
Great. Maria, your comments?
I would like to give it a different spin to that. I would like to look at it that you go to platform as a service because you have more than two servers in the way that you actually get the benefits of it. I see it as kind of the next generation to really enable kind of software and programmers to be able to be created in a much easier way. It's not so much, I don't see platform as a service so much as an operation model to automate the underlayer, but more as a platform or a model that gives you services that can accelerate your solution. That means if you're going to create a solution for a particular industry that you're in, you probably want to go to a platform as a service in the way that you don't have to worry about a lot of the infrastructure details that perhaps are not of your interest. However, you do need to keep in mind that as you go up the ladder on the cloud services, you give up a lot of control. But is that a control that is a differentiation for you? That's kind of the question. If it's not a control part that differentiates you, then don't do it. Other things that I would recommend that anything that you do, always create an abstraction layer. That means create your own services, doesn't matter to which platform you go, and make sure that the platform that you go to, it provides you the services and lower your cost.
Yeah, so from my point of view, platform as a service is a couple of things. Well, probably several things. I certainly agree with the notion that it's about levels of abstraction, being at a much higher level of abstraction than hardware. And certainly, over the last decade, the Java EE platform, a lot of people look at Java app servers as though they are a platform that's run as a service with an absolutely gargantuan API set. But there's this other sort of axis of sort of like what are the services that are available, and what do you need, and when people are building their own applications, they're creating a certain number of applications and then they're consuming a certain number of applications. So when you talk about a sort of a cloud application, it's going to have a bunch of its own components and then a bunch of outside things that it talks to. And how do you stand up all of those? And then there's this other whole axis of how do you do sort of multiple instances of a cloud? So somebody might think of they've got some application that represents what their company does, and they've got it running in production. But then you've got to have instances of the same cloud running in testing, and whether it's load testing, quality testing, different development groups, they need to have what look like multiple instances of the same cloud tying into some version of the same services. And how do you come up with sort of a uniform description of what an environment is, not just as a server image or a set of parameters to that server image, but a complete assemblage of all the components and all the things that sit around. And then, you tie all those pieces together, and suddenly you get something that's really remarkably useful.
That's great. I think all of you touched on sort of the abstraction aspect of it, right? So obviously, we're used to sort of the hardware layer, then the operating system. There's some level of virtualization. Then you get into some capabilities that help you, either develop or run the applications. And then you also touched on sort of interoperability. Can you, in that stack, sort of talk about where things are now and where do you think, they should settle in the future, if they should settle at one point? Or is it going to be always sort of, a different solution for every use case? And let me start with James, you on this time.
I mean, in the world that I live in, I try, so I'm kind of wearing 3 hats today, right? One is, I've been involved as a technical advisor to this company called Cumulogic, who has a really great PaaS management app. Past involvement in sort of the Java EE app server. And my day job these days is doing cloud applications for a company called Liquid Robotics, right? We do robots that roam the oceans collecting data. And they have a set of strange constraints on them. But at some level, the needs that we have are pretty normal, right? In the sense that, when I look at what a Java EE app server does, it's fine. I'm happy. It does everything that I need, and the bits that aren't there for me are the sort of management pieces, right? And there's a lot of management stuff available in app servers today. But there's a lot more that's needed, and it's particularly this issue of how do you handle sort of assemblages of things and the components that they interact with.
So what you're suggesting is that the level of abstraction is sort of use case dependent to some extent.
Well, it's sort of a mixture, right? So there are some components that are really common, right? So like a database is really common. The fact that most apps need some kind of database somewhere, and most of the databases kind of look the same.
Right.
A lot of apps need some kind of a messaging bus. A lot of apps need, some kind of like a mail system so you can send spam.
Right.
There's probably a dozen or so kind of like standard services that are common across all industries.
Right.
And then as you start picking silos, you sort of get some amount of narrowness. Right. So like in the case of the Cumulogic app, they know how to manage things like message buses and databases. And so when you spin up a cloud, you just say, I need a database. And you can talk about it more narrowly. But it's really good at sort of dealing with these assemblages.
Yeah. Maria, I know you talked about sort of it being sort of a next generation software programming or enabling the programmers. But where do you, in your world, sort of, where does the abstraction sit for the platform?
Well, I believe that you need to have abstraction layers, but depends of what you're doing. You want to use different types of abstractions. One of the issues that cloud computing brings is that everything is abstract, okay? And your virtual network is completely abstract, and that can bring a lot of issues. Then when you go to a cloud provider and you're selecting a platform, you want to make sure that the abstractions that they give you are based on underlayer technology that optimize what you're trying to do. Maybe somebody's looking for minimum requirements, then any cloud will be good for them. But some customers are looking for very intense compute loads. Maybe other customers are looking for a service that requires a lot of data transfer. Then they're trying to optimize for how they're going to do the compression and the packaging around the network. Then not all the clouds are done equally, And not all the platform services are done equally. Some platforms do just basic SQL databases. Other ones do basic non-SQL databases. Some of them do just the basic Hadoop. Others do versions of Hadoop that are optimized for the loads that they're going to do. That means that when you go to a platform, yes, they're going to have an SQL or a database, and depending on what type of database you want to use for your system, makes a huge difference what platform you're going to select. Because if you want to optimize for service or for uptime or for serviceability, you're going to have a different type of database that if you're trying to use one that is going to be more reliable and that you want to make sure that it's not eventually consistent, but consistently at all times, then there's always, I know that all of you guys know about everything about CAT, correct? You have to balance what you're going to be optimizing. And when you go to the cloud, you're going to have sections of databases in one or the other. You're going to have partitioning. And as you're going to have partitioning, you're going to have to make a choice. If you're going to optimize for your accessibility or if you're going to optimize for the accuracy of the data that you're going to have. And that trade-off, usually it is reflected in the platform. Then when you select the platform, you need to know which one you want to do that satisfy the load that you're going to do. Then differentiation actually, it's a very tricky word because you say, what type of abstraction layer? Well, when you go to the cloud, it's not just about having a messaging system, which do agree that we need to have a messaging system, but then you can have a messaging system that is real time or a messaging system that is just ensure that the message gets sent, but who knows when it gets there, okay? It might get there tomorrow. Then that makes a big difference on the application that you're going to be doing. Then there's a platform that you might want to use for your data, another platform that you might want to use for your message, and you yet might have another platform that you want to use for your social media that you have on your website. Then what do I foresee as a platform as a service in the future? You might disagree with me, but I see really there is a big market there for the interoperability, but also a big market for the integration. Platform as a service is really creating the role of integration across multiple different possible platforms.
Thanks. Steve, obviously you provide Azure as a service, and how do you decide what gets in there and what stays out?
Yeah, actually, I think going back to your original question, I think there will always be some level of healthy tension between innovation and standards, right? And we've all experienced that in various levels where, the pace of innovation at one point, and ultimately we agree on a set of standards on how to draw the line, which enables us to get agreement on some common pieces of technology that we then build on going forward. And I think in early days of the cloud, we would continue to expect that we're in an innovation portion of the curve, and over time we should expect to see some level of standardization that will make interoperability between scenarios more readily available. We do a lot of things today to make the lives of the developers easier, whether they're using .NET or they're using Java through the SDKs that we provide, so they're able to write code in the language that they want. But I think what's far more interesting than either of those things is, I would say, a significant number of our customers today, approaching 50%, use a combination of multiple providers in their application, and that's something that we embrace and we expect to see as part of the next generation of computation. And there'll be different reasons why you use different providers for different things, and making sure we do a good job as an industry of the interoperability between those points, either through standardization or just through vendor-to-vendor interop, we think is important to the evolution of the cloud. We're not going to be successful as an industry if this is a silo. We just won't. And we all recognize that the advancement of our industry is dependent on the extent to which it's easy to do mix and match and get the best out of each provider.
Oh, that's great. Hopefully we can leave all the vendor lock-in issues behind us, huh? Well, you talked about automation, and clearly, there's a lot of stuff which used to happen manually, and some of it is getting automated. But give us a view on, how far we have come, how much runway there is with what more can be automated.
Sure.
And maybe give an example of something that you feel is a cool automation that's in the products you see.
Automation of technology is everywhere. You probably experienced it just in the last 24 hours. I mean, just starting at the lowest level at the platform and building up from there. What was it like to plug in a printer to a computer 10 years ago, right? Or any external device? Did you have the right COM cable? Did you have the right LTP cable? Was it set just exactly right? Was it 25 pin versus something else, right? We mostly standardized on USB. What happens when you plug into that computer now? Either have the driver locally or it goes and gets it. If you're connected to the network, it spins it up, it deploys it. How much easier is that scenario now versus what it was just a few years ago? I think we have the moral equivalent of that in the cloud. We're working harder and harder and harder to get there. And we're not plug and play by any stretch of the imagination. But think about how far we've come at that level of the puzzle, right, in the last few years. And we're going to continue to work such that we do more recognition and understanding and we obfuscate some of the complexities about interoperability between clouds, because it's not the kind of stuff that most people want to differentiate their organization on, right? It's not the kind of stuff you want to burn time on. It's the inverse of what we talked about this morning in terms of urgent versus important. And truth be told, it's neither, right? So that's kind of stuff we continue to think will just get easier through innovation.
Do you think there's a lot of runway on the automation front?
Absolutely.
Okay. Maria, how about you?
I hope that we do it faster than what we did with plug and play, my God. That took a lot forever.
Yeah.
That's great. James? What do you
Yeah,
think?
I mean, the automation thing, in some sense, it sort of, for me, it sort of plays up against kind of the definition of PaaS, of platform as a service. You can view any of the things that we've been doing for years as being platform as a service. But when you go to any of the big installations, you go to the guts of FedEx or Morgan Stanley or whatever, they've always got these big IT organizations, and they have a management system that's, on average, a whole bunch of shell scripts, and it's really creaky, and they get by on it, and there's a whole lot of pain, and they need something. And that for me spells, demand for, a lot of these sort of high-level platform management systems and operation systems that people have been talking about.
Great, James. For there is, private cloud, public cloud within the broader cloud discussion. And where do they intersect with sort of PaaS, and what is the value to the end user to have a public or private platform as a service?
So wearing my day job hat, the company that I work for right now, we have a really interesting problem in that most of the time, a public cloud works just great, and yet we have customers for whom a public cloud is never going to work. We can't argue with them, nothing, some of them have data sovereignty issues, some of them have regulatory issues, between government bureaucracies and scary people. There are lots of reasons why we have customers that need private clouds. And in fact, that's one of the reasons that I'm a big fan of the whole sort of PaaS notion, and it's why I ended up on the board of Cumulogic, because you want to be able to not only be able to take your app and deploy it to the cloud, but you want to be able to deploy it to this cloud, that cloud, the other cloud. And in fact, you want to be able to take your suite of applications, bundle them up, send them in a box to somebody who's God knows where, and have them deploy that to their cloud. And there are loads of people that have this kind of conflict of interest between whether they can deal with public clouds and whether they can deal with private clouds. And even for people who are happy with private clouds, they grow to a certain point, they look at their Amazon bill and they go, oh my God, it's cheaper to build my own data center. And I know people who have had that moment, And it's not something where you can like pick an either or.
Sure, yeah. Maria, how about for you? How does private or public cloud intersect with the notion of platform as a service?
Well, as I said before, for me, cloud is a risk trade-off. That means that, yes, you might get your bill from Amazon and say, oh my God, I could have built my own data center for this price. But the reality is that you were taking considerations, risk on saying, well, I might not consume as much, correct? When you buy the capital, it's a commitment that you're going to have that load and that you're going to be able to support up to a certain peak. That means that a compromise here could be to, if you believe that you know pretty sure how much is going to be your load and you only need for certain peaks and your peaks are unknowns and you don't have, the ability to predict exactly what they're going to be, utilizing what is called an overflow into a public cloud is very useful because it's basically an insurance that you have that if for any reason you get an unpredicted load, you don't lose that opportunity to do that business. And you don't have a long-term commitment to having that capital. It might be more expensive for you for 1 month versus having your own capital, but if you look at it from the long haul and the overall return on the investment probably will be a lower cost. Then I see hybrid clouds, which is the combination between public and private cloud. I see hybrid clouds as a very good model because you can have all the good things of having your control over your IT, of having your own processes, having things controlled, not necessarily internet, and at the same time, have this extra capacity that you can use if you want to, and you can use a public cloud for much lower cost or non-differentiated loads that you want to do. Then I see, as a complementary to IT. I don't see that IT is becoming irrelevant with the coming of cloud. Okay. I see IT as a transformation. I see IT as basically enabling cloud computing for their purposes and a new vehicle to consumption. But they still need to do a lot of architecture, a lot of design, their processes, their solution. There is a ton of things. We're just automating and just going to standardize those things that don't produce value.
Yeah. So could I just leap in here because I
love. Can I stop you then?
Well, no, probably not.
Stop. Exactly. That's what
probably
I thought.
Probably not. Right. Yeah, I know. I'm loud and obnoxious.
Go ahead. I love to hear you.
So you mentioned the point about the role of IT, and I think that that's particularly relevant for people who have private clouds. Whether for whatever reason, they have private clouds. And when you look at what happens in IT organizations today, you end up with this weird relationship between the IT organizations and all the other different parts of the company, right? You often have other different parts of the company that have their own software developers, and they need some machine resources, and they go and they talk to the IT organization, and the IT organization gives them some bullshit about, budgets and all of this kind of stuff. And, it just like falls apart, and the people out in the department, they pull out their credit card and they go to the Amazon website or the Rackspace website and they just do it. And they solve the warfare between IT and the rest of the business just by basically voting with their feet. Right, and then you end up with companies that have no clue what their IT budget actually is because it's been distributed amongst a whole bunch of little departments who have got like their independent credit card accounts with Amazon or whoever. And one of the things that I like about some of the past management solutions that deal with private clouds is that they can sort of break the warfare between the IT department and the divisions, because they allow people in the divisions to access the IT facilities the way they would access Amazon, or even at like a higher level than Amazon. So Cumologic does this, and Eucalyptus does this, although the Cumologic stuff is at a much higher level than Eucalyptus. And it can really, you know, it can actually bring peace. You know, it's not like it makes the IT department irrelevant. It can actually bring peace between the development organizations and the IT organization, and actually make the IT organization more relevant to the businesses than it had been before.
That's interesting. So you think...
I want to add one more point here.
Okay, please.
Sorry, we will let Steve talk, but I completely agree with you. Cloud computing actually is accelerating a lot of the innovation, and then when that innovation is realized, then the IT department can actually create more value. I see a lot of what is going on the GORPs of cloud computing, especially in the infrastructure as a service, is this standardization of part of IT that not necessarily are providing value to a lot of the IT organization. And I think that the example that Steve provided on the USB cable is very apropos in this example, because in the future you just only care that your database is running and that you have access to your storage or that you have access to your network. You're not going to care exactly how that thing was configured. Then that type of standardization is going to create a transparency that we don't really have today. But we're not there yet, though.
Okay, so that's good. I mean, I think you two have given a private cloud, the platform as a service as a role to intermediate between IT and business, as well as all the other, you know, efficiencies that it can bring. But Steve, from where you sit, do we need the distinction between private and public as we go to platform as a service, or is it going to go away?
Yeah, no, it's an interesting question. I think the tension between business and IT is healthy. It is healthy and it is tension, right? It is both of those things, and it's good. I mean, how many people lived through the web server days, right? Where we saw the explosion of web servers, and then before you know it, every person across their company had a little web server running under their desk, right? It took IT a little while. We developed best practices. We consolidated, figured out what was the right economic model, gave the right level of flexibility back to the business, and we all evolved. That trend will continue. We will do this again. We're doing it right now, right? With the corporate credit cards that are being used to buy IT services externally when we think the business isn't keeping pace. This will happen again in some other instantiation. We will see this, and it's good. Healthy tension is good. I think going back to the private versus public PaaS conversation for a second, the most important thing that I would leave you with on that topic is know why. Know why you're using public, know why you're using private, and know what the pros and cons of the other are. If you're doing it for compliance reasons or regulatory reasons, then you know why. The other part of the conversation doesn't matter. If you're doing it, you think because economics, make sure you do the math on the other side. You might be surprised. So I think in this particular conversation that we have over and over with customers, it's more about knowing exactly what it is you're trying to accomplish with the private versus public. And actually that journey, getting to the know, is more valuable than the end answer itself. You'll learn a lot more about how to think about the next generation of your IT by knowing what your constraints are.
That's great. That's great. We'll leave 5 minutes for Q&A from the audience. So after a couple more questions, I think we'll be ready to take some. So please do think about your questions. Let's now switch sides. You know, we've been talking sort of the definitional side, the more technical sides, but let's step into the shoes of the users who actually use these services and think about the value proposition they get, right? So first, you know, if each of you could sort of provide an example use case which sort of shows the potential for what PaaS is and will be in the future, you know, whatever you feel is sort of the best example of that. So Steve, we'll start with you.
Sure. Tons of examples. We see them on the web every day. Whether you're using a framework to build a web application and you're starting fairly high in the stack to build it, or you're using a blogging framework, whatever it might be. These are all examples of where you want to begin and where you want to innovate. And I think we'll continue to see more and more of these kinds of examples over time. There's opportunities for organizations to come in and build higher levels of infrastructure to start even higher in either the web or the core application side. We talked about Service Bus. We talked about a few things where we think there's opportunities for innovation, and that will That will continue, and we should expect it. Remember though, every time you use one of those top-line frameworks, you are constraining yourself, right? You are losing the ability to dive deeper into that stack and make those modifications that you want. And I think the right way to approach this is that a trade-off I'm willing to make? Do I feel good about that? And if the answer is yes, then move forward. But you are limiting yourself every time you do that. And that may be okay.
Maria?
I want you to think that platforms are many, many, from A to Z, literally. We have the list of all the different platforms that we have, and we have from database as a service, from network as a service, platform as a service, all kind of different platforms. Then I don't want you to think in terms of I need to make a decision on which is the platform I'm going to be using. Instead, think in terms of what is the solution that you want to do and which are the different services from the different platforms that you want to utilize. And try to think in terms of you as the integrator a lot of those services in the way that you have the richer experience and the most value on cloud services.
James?
Yeah, I mean, you were asking about sort of examples, and I guess the example that I know best is my day job. But to echo Steve's point, right? It's he talked a lot about actually doing the measurements, right? Trying to understand what your app is, and for lots of folks, it's not what your app is; it's what all the pieces are. So like in my case, right? We have robots roving the ocean. We literally have robots roving the ocean, and a lot of them. And so we have parts of our system that are about sort of command and control of fleets of robots. We don't have like a big data problem with them because our communication channel is the Iridium network, and at $1 a kilobyte, you're not doing, a terabyte of data, it costs you $1 billion, not going there. But, if we lose communication, if our data center is taken down, we now have a fleet of robots all over the world that are just going goofy, right? So we have, we have a serious reliability issue, but not a data volume issue.
Where is
right?
in that example, where is the platform?
Well, we have multiple platforms, right? I mean, in the control planes, we actually use .NET in part of it. We use Java EE for a big bunch of it. The onboard stuff is a dog's breakfast that you don't want to know about. And as you go across the different aspects of our systems, right? We've got the piloting stuff that has a really, really stringent reliability issue, and then we've got things like the data aggregation, data presentation, data grinding stuff. That's got a whole different set of issues. We've got sort of what's roughly mission planning, where a customer says, has a thing that says, I want, measurements of, hydrocarbons, around, the Macondo oil well, and so you can have a robot just orbit that, right? So that, there's sort of the mission planning level that's, got kind of a strong reliability issue, almost no data issue. Piloting has got a really strong reliability issue. The science data that comes off sometimes has a really big data issue because you've got like different kind of communication channels. And so we end up having to slice or dice our whole universe into, half a dozen-ish major stacks. And they all actually have quite different trade-offs.
So my next question is about, all of you sort of mentioned how easy it is to use a credit card and, use infrastructure as a service. So the deploying of, platform as a service, how easy was it for you to do the platform for the roving robots?
Well, right now I have a standard server image at my hosting provider that, and I just say spin up a bunch of them, and they all run Glassfish, which is a Java EE app server, and that's my platform, right? Is Java EE, and then I deploy, individual applications to whatever, and so I treat sort of the Java EE level as my platform as a service, and of course it's way more manual than it needs to be. Because I, at some level, actually have to configure CentOS and all the horrible stuff that goes on in there.
Sure.
But once you've got a server image and you can replicate that and then view that as a platform, life gets somewhat easier.
Sure. So Maria, how easy is this to deploy platform as a service, say, compared to infrastructure as a service?
From the provider perspective or from the consumer perspective?
From the end user perspective.
From the end user perspective, it's much easier to use a platform as a service than an infrastructure as a service. If you're going to do an infrastructure as a service, you need to worry about how many servers you need to do. You actually need to go and instantiate the virtual machines. You need to select which image you want for the virtual machines. You need to make sure that you patch the virtual machines. You need to have the virtual firewalls between the virtual machines. You have to have a loading between the virtual machines. You have to do the network taxonomy between the virtual machines. I mean, everything is virtualized, but you have to do the same step that you used to do before with all your systems. Nothing has changed. You have to make sure that you put them in the routine to patch them. You had to do the scripting to do all of that. You had to monitoring them to make sure that they're down, and when they're down, what is the scripting or how you're going to replace the next thing. Because, for example, if you're doing Amazon doesn't do anything automatic, right? You had to do your own scripting and do your own little code to make sure that when your server goes down, it instantiates another one. I'm not saying, it's much better than having your own physical servers,
right.
But it still is a lot of work. If you're in a platform as a service and you just want to allocate a new table, for example, for a data source, you don't really need to worry about how many virtual machines you need to instantiate. It's already under the layer. You only worry about that, just create this table and get this much data. And then you just worry about those APIs that you're calling. Then that level of abstraction, it does simplify a lot the life of a programmer that is trying to create a solution. Then I personally believe from the consumer perspective is much easier. However, you have a lot of other constraints. For example, if you go in a database as a service, you don't have control of who else is sharing that database with you, because it's a shared database.
Sure.
You don't have constraints about how many other users are in that same virtual machine. The security level is much lower. If for any reason somebody happens to want to attack that service, since the platform as a service now become bigger targets.
Right.
I'm not sure how many wants to attack this little glass, what do you call it, glass fish, or what is it?
Well, that's the app server, but our robots are...
Yeah, I don't know if it's in the top of the list of, let's attack the robots, they are going in the water, correct? I don't know if that is in the top list.
Depends on who the customer is.
Oh, okay, I don't know. But most people want to attack things that have money. Most people want to attack things that give them money, That's the money, where's the money now? The money is not in the banks, correct? The money is in the clouds now, correct? Then everybody wants to go to the clouds and get the data. That's where the currency is. Having the data is the new currency. Having access to the clouds and attack where people are doing transactions, that's where the money is. That means that if you go to a platform, most likely there's going to be more attacks on that if you do a little thing there. But on the other hand, you're going to have more services applied to that. That means that there is a balance here from the simplicity perspective on how easy go to market. If you want to do a solution, going platform as a service is much easier.
Great. Steve, your comments on what is it like to deploy on a platform?
Sure, I could tell you, but it'd be easier, just go try it. WindowsAzure.com, get yourself a free 90-day account, download the SDK, and deploy it in the past.
That was
Give it
not
a shot.
fair. And you can go to 1 million.
It's really, see for yourself. use it in the Visual Studio environment, build out an app, and just deploy directly from a development environment into the cloud and go F5 and see that it's there. Check it out.
That's
You can
great.
go to IBM Smart Cloud too.
We still have a few minutes. We still have a few minutes for some questions we can take from the audiences. Any questions there? Please. Can we get a mic over there?
Thank you. Question to Dr. Gosling. Really, I mean, you have been through the various IT evolution since early 80s. You've seen the industry going from different phases. So just one quick question. Where do you see the technological breakthrough will come in cloud computing in next 5 to 10 years? What type of startup companies in cloud computing we should see?
Boy, hey, you know, if I could answer that one,
You don't need to sit here.
yeah, I don't need to sit here. That's for sure.
But James,
But you know, the hard problem in the cloud world these days is this combination of sort of management and sort of security. You know, if somebody could figure out how to do, say, HIPAA compliant apps in the cloud, that would be really cool. I think there's a theorem somewhere that says it can't be done. But, you know, boy, would that be nice. And that's actually part of my problem, right? You know, in my day job, I have some data that is as sensitive as you know, healthcare information. And, you know, the cloud world isn't well, it's sort of getting closer every day, but you know, that's a rocket science problem. The management problem, I mean, there's this interesting balance in the management problem in that you can make the management problem easier the more you narrow the platform. And nobody's got a really good sort of broad management answer that is also easy.
That's great. I'll give 30 seconds to Maria and Steve as well to comment on what are the open challenges that you're addressing where there's future opportunities.
Well, a large percentage of our customers are banks and the health industry also. We have a lot of hospitals and a lot of insurance. That means that we have a vested interest on being able to do a HIPAA compliant cloud. And I don't think that nobody has proven yet that cannot be done, but I can tell you it's very hard. It is very hard, and you have to change a lot of the underlayer of your cloud, and it's going to basically be a service that is a premium service. That means it's not going to be a cloud that anybody just going to go to use. It's only those that, because of government regulations, will have to pay that premium, and then we need to think back about our own regulations, correct? Because that premium that everybody's paying for that data is really being reflected on our healthcare. Then there's a lot of pressures here that we're going to be experimenting with in the future, and a lot of our business models will change if some of the laws are changed.
So Steve, so we should all be going and building HIPAA compliant cloud solutions?
Or rely on partners that do. That's another way to look at it. I think, going back to the question, the demand for compute on this planet is insatiable, right? I mean, Dr. Moore gave us this great algorithm that helped us understand that computing power was going to effectively double every 2 years, and it has. And even as we ran out of clock speed, we got into cores, and as cores are doing what they're doing, we're finding other ways to continue to add capacity. And yet, the number of servers that ship every year continues to grow. It continues to grow. And whether we've talked about virtualization, or cores exploding, or clock speed increasing, the demand for compute is insatiable. And I think what cloud allows us to do is to move to an utilization level that allows for more innovation, right? It's going to take a lot of capacity that's otherwise sitting around dark, and in an economic model that makes sense. Expose it to people to do interesting things, right? Think about 80% of the total cloud, total computing capacity right now being unused, right?
And as more as that shifts to an availability model, it will be available for you to do interesting things. So
That's great.
brace yourself. This is just the beginning.
I think there's one back there, Arijit.
Yeah, Maria, earlier today you were talking about how most of the security problems are coming from the people. And just a few minutes back, when the most important thing came up, it again came back to privacy and security. PwC talks about 40-50% problems coming from people. Well, if you're on the cloud and if it's abstraction and you're going to solve it for us, what are you doing to solve it? And this is to all the speakers, of course.
So what are you doing to solve security problems?
At the people level, at the
people
information
level.
theft by humans level.
What are we doing to address the people? Well, one of the things that we do to address the people issue is a lot of the screening. A lot of the people that are working on our clouds, they're screened. We're doing a lot of physical security in the way that when people get into the data centers, they have to use a lot of biometrics in the way that we know for sure that the people that are getting in are the people that we have allowed in. However, since this is value concentration, what is happening in the cloud, there's a lot of temptation, correct? Because you're dealing with data that is very sensitive and data that people outside are willing to pay substantial amount of money to corrupt the people that you're hiring. That means that there is a trade-off there too on the individuals, correct? The risk is high, but the rewards can be high too, because there is a lot of people willing to pay substantial amount of money for all of that data. Then what we're doing is we're creating basically monitoring. I don't know if you guys are familiar with point of sale technology, that when you get into a point of sale, you log in yourself and they log everything that the person had been done that. Like when you go to Burger King or McDonald's, I don't know if so many of you guys, when you were in college, worked there, but when you go to a point of sale, the first thing that you need to do is to put your code name and they track who was in the cashier for that time. We're doing exactly the same thing on our clouds. That means that when you go as an administrator and you go and do anything, all the functions are done as is. That's basically the code here. That means that you put your code and you do a transaction as is, and we know exactly who has been doing those transactions. However, this is where the people factor comes in. If you're sick and then you call somebody and say, oh, would you do this? I forgot to do this thing. Please go ahead. This is my password. Here it goes. Doesn't matter how many technologies we have put in the world in that cloud. If we have people, correct, that do that, okay, then we train people to not to do that. I train people that if we discover that something has been done and it's under your name, then you will be fired. Okay? Then don't be giving your name and your password away. But then there is a lot of other issues, correct? I mean, there is rootkits that can get into the cloud and they can monitor all the password that people are writing, correct? That means that we need to do a lot of, checking to make sure that the servers are not being compromised, and that's why we're doing a lot of the safe boots, okay? And that's why a lot of the systems are in rotational booting, in the way that if we get a rootkit or if we get some type of compromising on the system, it's only within the last, 24 hours, 12 hours, because everything gets constantly monitored. However, the weakest link is the individual. And the more technology we throw at the problem, the more innovation the criminals come up with, okay? Then sometimes they only need to have access to a data and put it in a piece of paper, write it, okay? Sometimes the most critical issues, the data is not that massive, okay? Like he was talking about, the problem is sometimes it's not the amount of data, but the key data that they're looking for. Then that is very difficult to monitor. Then we do have cameras everywhere. We have experienced all kind of different problems with that, and we use a lot of the monitoring in the cameras for that.
Great.
However, I don't foresee that this will be 100% close, because human factors has been for thousands of years and it will continue being that way.
Right. We have time for just about 30 seconds on Steve. What do you think? What are we doing to handle human security issues?
Yeah, it's a part of reality of of technology. It has been since the beginning. It's going to continue to be an issue. I think one of the things that people tend to think of is wonder if is there more security in obscurity. If I'm off by myself and nobody really knows about me, am I more secure than am I bundled? The counter to that is when you're using a cloud provider, you've got an organization who has a vested interest in keeping your protection to the best that they possibly can. And they're working hard to do it through networking side and a variety of other contexts. So I think it's important to understand both sides of that equation.
Great. James, any comments on what is being done for securing? More from the preliminary front.
Yeah, I guess, I mean, people are doing a lot of technical stuff around securing. At some level, it's sort of hopeless, right? Because the criminals are always innovating, and that leads to this sort of category of customers where it doesn't matter how good your security is, how many security audits you pass. Their answer is no. Right? Unless we've got the data in our site,
right,
with an air gap around it, and a bunch of guys with concertina wire and machine guns, we're not going to trust you.
Right.
Right. And so that's the kind of thing that for me drives the separation between public and private. Right, because you could do a lot to make the public clouds way more secure, and I would love to get to a day where they can be so good that people's security issues with them just go away, but ain't going to happen.
Great.
At least not in my lifetime.
Thank you. That will conclude our panel. I'm getting warning shots here. First, join me in thanking the panelists. For the comments and insights. Thank you, Steve. Thanks, Steve. Thank you. Oops. Yeah. There we go. Thank you, Maria.
Hi, we'd like to quickly announce the winners of the fastest growing cloud company before we move into a short break. And I'd like to invite Jeff Nick with EMC back on stage to share with us how the judges decided. Okay, maybe while Jeff's coming up, let's share the results of the audience vote. No? Okay, so who do you think should win the fastest growing cloud computing company award? Cloudflare got 63% of the vote. Congratulations. And Jeff, how did the judges roll? Okay. Sorry.
So first of all, I'd like to say that the judges felt that all three of these companies had a very compelling value proposition. So it was a difficult judging decision, especially that they're in such various diverse industry spaces and technology verticals, and it was kind of one of us commented it's kind of like judging a dog show of a poodle against a Belgian shepherd. It's just a little challenging, but at the end of the day, we thought that the company that most strongly represented and had its finger on the pulse of issues associated with cloud computing and was also fast growing was RightScale.
So if we could get RightScale and Cloudflare to come on stage. There we go. Both of you can come on up next. So Jeff, that's for you.
Thank you.
Cloudflare.
Very much.
Thank you very much. Congratulations. Thank you.
Thanks.
Great, thank you very much, and thank you for your participation in the audience voting. We are going to break, and we're going to reconvene at 3:45, so we'll be back shortly. Thanks.